In the previous chapter, we successfully enriched our ontological foundation. We progressed from the axiomatic vacuum pure consistency imposes, and introduced existence, causality, space, and motion. Still, as we mentioned many times in the previous chapter, without spanning and hosting additional dimensions, the world we described must be empty. Therefore, in this chapter, we will populate this world with matter. Still, similarly to the previous chapter, the issues we will discuss will be challenging. Because this chapter must confront complex nuances of physics, understanding it will not be easy. While the concepts we will discuss in this chapter are not alien to the world of physics, without a theoretical background in physics to put it in context, the issues we will discuss in this chapter might be confusing. Moreover, again, because providing a metaphysical explanation for physics is not the goal of our journey, we will discuss these issues only in brief, and therefore, you might find the rate at which we will conduct our discussion overwhelming. Nevertheless, complex as it is, understanding this chapter is a necessary milestone in our journey towards the essence of our consciousness. Therefore, I suggest that similarly to the previous chapter, if you have the spare time, listen to this chapter, read it again, think about it, then listen to it one more time, until you feel you understood the ideas this chapter discusses, to a level you find sufficient. Undoubtedly, the essence of matter is fickle. Obviously, matter affects our consciousness. We perceive the world through its materialistic manifestations, and in many ways, our acquaintance with matter defines our concept of existence. In fact, arguably, the only reason we perceive space and motion is because matter propagates it. To explain, to perceive space, we must sense physical elements, with sight, sounds, smell, taste, or touch. The same applies to motion. To perceive physical motion, we must sense the movement of physical elements. Therefore, our acquaintance with matter is confusing. We think the matter we sense is the essence of matter, and therefore we overlook the dimensional complexity matter propagates. We fail to separate the existence of matter from its spatial and temporal existence. However, as we explained in the previous chapter, the dimensions of existence, causality, space, and motion merely sustain the existence of elements in space and time. On their own, the four dimensions we reviewed can yield nothing but empty space. Therefore, for matter to exist, the world must sustain additional regularities. Indeed, as we just hinted, similarly to the dimension of space, the formation of matter might require the involvement of several regularities, or alternatively, dimensions. Still, to ease our discussion, similarly to the manner we discussed the dimension of space, we will generalize this possibly complex dimensional cluster, and name it, the dimension of matter. The dimension of matter solves the contradictive stagnating equilibrium of the infinite flow, by determining that within our world, all flows of causality, consistent with both themselves, and all the other consistent flows of causality the world harbors, exist. Still, what does that mean? Well, the truth is, we have been delaying the discussion regarding this issue for quite a while. To explain, repeatedly we mentioned that the world is an existing logical construct. Still, we did not provide a proper definition for existing logical constructs. Arguably, up until now, we did not really require such a definition. The world we described so far was empty of elements. However, this is only partially true. The dimensions we described are existing logical constructs as well, and therefore, arguably, we should have discussed this issue before. Still, this issue was not as pressing as it becomes once we approach the material world. Unlike the empty space we discussed in the previous chapter, intuitively, matter is anything but abstract. We can sense its existence. Moreover, we can measure its regulative behavior. We can measure the validity of physical equations. Therefore, we can no longer delay this discussion. We must unite our metaphysical foundation with our empirical knowledge. Essentially, existing logical constructs are similar to abstract logical systems. Both demand the existence of atomic elements, and both allow a narrow and strict set of rules of inference. However, unlike abstract logical systems, existing logical constructs are not the product of our thoughts about them. In other words, existing logical constructs are neither the product of axioms existing in our minds, nor of our cognitive ability to apply rules of inference on axioms. Instead, existing logical constructs replace the axioms abstract logical systems impose, with the existing imperative regularities our world imposes on all the elements it harbors. In other words, existing logical constructs replace axioms with dimensions. Still, as we explained in the previous chapter, dimensions are independent of one another. Therefore, there are no inference relations between them. To explain, considering the dimension of space, its spatial expansion exists because this is what spatiality demands, regardless if it sustains motion or causality, or if it persists in time. Therefore, in logical terms, the existence of a dimension is equivalent to a tautology, as it follows the formula of tautologies, meaning, if X exists, then X exists. The existence of a dimension cannot depend on a previous set of dimensions. It exists because it can exist, as nothing negates its existence. Moreover, the existence of a dimension is independent of our recognition it exists. It is self-evident. To summarize, logically, a single existing logical construct cannot impose any rule of inference other than the tautological nature of its existence. To apply logical rules of inference on existing logical constructs, several existing logical constructs must interact. Still, again, because the dimensions or world spans are independent of one another, we cannot apply any logical rule of inference between them. We can only apply logical rules of inference between the world and the elements this world hosts. For example, considering the dimension of motion, using the logical rule of inference, mod use ponens, we can deduce that if a world sustains the dimension of motion, then any element within it, let us say, element X, must exhibit change. To clarify, we can refine this statement in logical terms. For example, let us analyze our last deduction. Our axioms are: 1. If an element exists in a world that spans the dimension of motion, it must sustain the regularity of change. 2. Our world is a world which spans the dimension of motion. 3. Element X exists in our world. Now, by applying the logical rule of inference, mod use ponens, on axioms 2 and 3, we can deduce that element X exists in a world which spans the dimension of motion. We can now apply the logical rule of inference, mod use ponens, again, on the product of our deduction, and axiom 1, and deduce that element X sustains the regularity of change. Still, axiom 1 is different from axioms 2 and 3. Only axiom 1 imposes a rule of inference. Axioms 2 and 3 are tautological. To clarify, axiom 3, meaning element X exists in our world, can only be valid if it is valid. Supposing we sense element X, nothing can refute we sense it, and if we do not, then axiom 3 means nothing. Considering axiom 2, meaning our world is a world which spans the dimension of motion, implicitly, it determines the existence of the dimensions of motion, existence, and causality. To clarify, axiom 2 implies our world enforces multidimensionality on all the elements it hosts. Therefore, essentially, axiom 2 is valid, simply because this is what our ontological foundation determines. We can choose to believe in this foundation or not. It is a tautology, which nothing can prove or refute, regardless of how sensible it is. However, again, axiom 1, meaning if an element exists in a world that spans the dimension of motion, it must sustain the regularity of change, is different. Contrary to axioms 2 and 3, axiom 1 is our partial, yet imperative logical outcome of our metaphysical foundation. In other words, axiom 1 is the only axiom which can serve as a rule of inference, as it is the only axiom which is not tautological, meaning it accepts and affects elements, it does not define. Scarce as it is, this is the inferential limit existing logical constructs allow. Dimensions enforce behaviors on the elements they host, while elements a world hosts cannot enforce behaviors on neither the dimensions which host them nor sibling elements residing in the same world with them. To explain, the physical logic dictates that all existing elements are dimensions. Moreover, the physical logic determines that all dimensions are independent of one another. Therefore, existing elements, or alternatively, dimensions, cannot affect one another, regardless if these elements are the dimensions a world spans, or the dimensions a world hosts. They can merely affect the state of either the world they span in, or the world that hosts them. The dimensions a world hosts determine the state of this world, and the dimension a world spans determine the manner this world persists. To clarify, the elements a world hosts impose a state on the dimensions a world spans. In turn, the dimensions a world spans impose the next state in which this world would be, meaning the next state in which the elements this world hosts would be. Therefore, the elements a world hosts cannot affect one another directly. They can merely affect the state at which other elements would be within the world that harbors them. Therefore, essentially, to affect one another, dimensions require the dimensions the world that hosts them spans. To explain, supposing two existing elements in the world collide. Metaphorically, these two colliding elements approach the dimensions the world spans and say, "Look, unless you do something about it, it appears we will both exist in the same point." In response, metaphorically, the dimensions the world spans answer, "Okay, got it. So this is what you are going to do. You are now going to repel from one another, or alternatively, you are now going to merge with one another." Still, again, dimensions are tautological. Dimensions are not aware of the elements they host. Metaphorically, from the perspective of a dimension, nothing exists but occurrences of itself. For example, metaphorically, the dimension of motion does not recognize the moving elements in our world. The dimension of motion merely recognizes motion, which is the regularity it sustains. To clarify, if an element a dimension hosts fails to comply with the regularity this dimension sustains, this element does not challenge this dimension with an inconsistency of some sort. The dimension simply ejects this element from it. In turn, metaphorically, once the dimension of causality notices this element is no longer consistent with this dimension, it ejects this element from the world altogether, as the regularity the dimension of causality sustains demands all the elements within our world must be consistent with all of the dimensions our world spans. Cosmologically, the tautological nature of dimensions produce various types of possible infinities. The dimension of existence produces the possible infinity of time. The dimension of causality produces possible dimensional infinity. The dimension of space produces the possible infinity of space. The dimension of motion converts our world into a type of perpetuum mobile. Therefore, intuitively, we could think the dimension of matter should allow the possibility our universe harbors an infinite amount of matter, or alternatively, mass. However, the regularity the dimension of matter sustains is different. The dimensions we described in the previous chapter produce independent infinities. We can rephrase this in mathematical terms and say that dimensions are orthogonal to each other. To explain, considering space and time, space could be infinitely large, while time could be finite, just as height could be infinite, while width could be finite. However, arguably, infinite mass requires an infinite space to harbor it. Therefore, the infinity of mass might be dependent on the infinity of space, and therefore, the infinity the dimension of matter sustains should be different. The independence between dimensions is not a nice-to-have feature. To explain, a dimension slices a segment from the logical field, which is consistent to it. If a dimension slices the same section, a different dimension already slices, it implies the other dimension is redundant, as another dimension already segments the logical field to the regularity it sustains. Therefore, this other dimension does nothing, and therefore, its existence is merely a definition. It is no longer an existing logical construct, and therefore, it cannot exist in the logical field. While we could argue that the dimension of matter slices matter in many different worlds, this does not change much. Even if the infinity of mass is multi-universal, it does not change the dependency between this infinity and the spaces that exist within the worlds which harbor it. Furthermore, there is an even more fundamental problem. According to the physical logic, the dimensions we discussed in the previous chapter exist everywhere in our world. We can find existence, causality, space, and motion in every corner of our world, while arguably, mass populates merely a small portion of it. Indeed, light and radiation may reach every corner of our universe, and therefore, we can assume that every corner of our universe is populated. Still, to the best of our knowledge, light and radiation are not matter. To summarize, the definition we gave to the dimension of matter, meaning the regularity, which allows the spatial-temporal existence of all flows consistent with themselves, and all the other flows existing in our world, is insufficient. We must explore the dimension of matter further. According to the conclusions we reached in the previous chapter, matter must be the product of consistent three-dimensional flows of causality. Furthermore, matter, or alternatively, particles, exist in our world, and therefore, to exist in the logical field, they must consist of dimensions. Still, assuming particles exist independently from one another, then naturally, the dimensions of which different discrete particles consist are not the dimensions our world spans. To explain, had particles consisted of merely the dimensions our world spans, nothing could slice and separate the regularities they sustain, and therefore, there could only be one particle in the world, contrary to our experience. To conclude, essentially, particles must impose relations between the dimensions our world spans and the dimensions of which they consist. Mathematics and geometry named such relations between dimensions as angles. We will do the same. Still, our definition of the term angle is more general than that of geometry, meaning a spatial relation between two two-dimensional entities. The angles we refer to determine relations between two dimensions, regardless if these dimensions are spatial or not. Moreover, unlike the angles in geometry, the angles we refer to are not numeric values. The angles we refer to impose existing regularities which occur between dimensions. They determine the manner by which causality flows within the dimensions a world spans. Therefore, to ease our terminological confusion, we will name the angles we refer to as dimensional angles. Dimensional angles determine the rules the elements a world hosts obey. Alternatively, dimensional angles are the rules of inference we previously discussed. Still, dimensional angles are not dimensions. They merely serve as means of argumentative simplification over the accumulation of causative complexity which multidimensionality imposes. Therefore, essentially, dimensional angles do not exist in our world. Still, dimensional angles refer to partial aspects of existing regularities, or alternatively, three-dimensional flows of causality exhibit. However, again, these are not the angles we know from geometry. The angles we know from geometry are generalizations. Physically, we do not encounter geometric angles. Angles are similar to the points we discussed in the previous chapter. We deduce them only abstractly. They are definitions we make, meaning, they belong in the inconsistent segment of the dimension of consistency. Still, how can we claim this? To clarify, in the previous chapter, we determined the dimension of space is both three-dimensional and an inherent part of our cosmology. Therefore, intuitively, we could think the dimension of space allows the existence of angles within it. However, now we claim otherwise. How can this be? Well, to understand why angles cannot exist in space, while dimensional angles can, first we should understand why space is three-dimensional. As we already mentioned, our world spans more than 3 dimensions. Moreover, obviously, one-dimensional singular worlds span less than 3 dimensions. However, within the logical field, hosting several elements side by side demands a 3-dimensional space. But why? Well, first, to host elements, a world must span 3 dimensions, meaning, existence, causality, and a hosting dimension. To explain, such a world must exist, and therefore, it must sustain a dimension of existence. Furthermore, obviously, to host several elements within it, it must span a hosting dimension. Last, to bind existence with this hosting dimension, it must span a dimension of causality. Still, there is an additional reason. As we mentioned in the previous chapter, the logical field can harbor space separately from all the other dimensions our world spans, just as it can harbor the dimensions of existence, causality, and motion, without the dimension of space. Therefore, for space to be an element which hosts other elements within it, independently from the dimensional cluster our world embodies, it must sustain 3 dimensions, similar to the dimensions we just mentioned. To explain, arguably, within the dimension of space, height, width, and depth translate into a dimensional trinity, similar to the trinity, which the dimensions of existence, causality, and an additional hosting dimension embody. For example, width translates into existence, meaning, existence along one plane. Height translates into the possibility of hosting an infinite amount of infinite, width planes, along it. Last, depth translates into the ability for elements, which possess both width and height, to interact in a manner consistent to width, height, and of course, depth. To summarize, arguably, the 3 spatial dimensions might not be spatial at all. Indeed, within our world, they produce the space in which we exist. However, arguably, they might not be different from any other dimensional trinity, within the logical field. Moreover, if this hypothesis is correct, there is no way to determine which of the 3 spatial dimensions is the dimension of existence, and which of the 3 spatial dimensions is the dimension of causality, or the additional hosting dimension, because arguably, none of these dimensions must demand spatiality. Therefore, if this hypothesis is correct, it is not surprising we can divide space into 3 spatial dimensions, subjectively. Regardless of the true identity of each of the 3 spatial dimensions, possibly our division of space into 3 spatial dimensions has little to do with the metaphysical regularities they sustain. Arguably, we might not divide space according to their metaphysical function. Possibly, we divide space merely in the manners we find meaningful and beneficial, and that is all there is to it. Moreover, considering our analogy between width, height, and depth, and the dimensions of existence, causality, and the additional hosting dimension, then arguably, it is possible there are no 3 spatial dimensions at all, but rather a single infinite hosting dimension. Indeed, our world appears 3-dimensional, and obviously, the vertical location of an element is different from its horizontal location, or its location along depth. Still, using the diagonalization mathematical technique, we can show a method by which we can squeeze a 3-dimensional space into a 1-dimensional space. However, again, this is only a hypothesis and arguably, its validity is of little significance. Still, regardless, by introducing dimensional angles into our terminology, we manage to avoid our intuitive fixation regarding spatiality. We disassociate angles from the geometric shapes in which we usually find them. Nevertheless, while indeed, angles do not exist in our world, our intuitions regarding angles can help us confront the regularities dimensional angles impose, which in turn can help us understand the nature of existing 3-dimensional flows of causality, and the manner by which they produce matter. To explain, suppose we tie a bucket to a rope, and rotate it in the air. If we stand still, as we rotate the bucket, the angle between us and the base of the bucket continuously changes. However, the angle between us and the base of the bucket does not exist in the world. To explain, from the perspective of another object, rotating around us at a different rotational speed than the bucket, the angle between us and the bucket would be different than the angle we perceive. Still, from our perspective, this rotation and motion does more than just change the angle between us and the bucket. As the bucket rotates, it creates the shape of a circle within our mind. The same applies to dimensional angles. Dimensional angles navigate 3-dimensional flows of causality in space. They continuously rotate 3-dimensional flows of causality in a manner consistent with the dimensions our world spans. Still, unlike our rotating bucket, dimensional angles do not rotate around an axis, but rather respond to the collective demands of the dimensions our world spans. To explain, because our world spans both the dimension of space and the dimension of motion, all elements within our world must always exhibit motion in all three spatial dimensions, as well as continuously change their direction in all three spatial dimensions. If we consider our old bucket, if it was to respond to such demands, its rotation would not produce the shape of a two-dimensional circle, but rather a three-dimensional ball. This analogy sheds some light to the manner by which three-dimensional flows of causality can produce matter. Nevertheless, it imposes an explanatory challenge as well. To clarify, first, while this bucket analogy helps us understand how movement in space creates the illusion of a shape, according to our metaphysical foundation, the existence of three-dimensional flows of causality is not an illusion. Arguably, it is the very essence of matter. Secondly, unlike the bucket, three-dimensional flows of causality are not a single point moving in space. As we explained in the previous chapter, points do not exist in our world, and therefore, naturally, they cannot move in our world. Therefore, a three-dimensional flow of causality cannot be any specific point progressing in space, but rather the entire path by which it progresses. In other words, to exist in our world, the entire path by which three-dimensional flows of causality progress in space must exist simultaneously. Moreover, because flows of causality are three-dimensional, the manner by which three-dimensional flows of causality progress in space is different from the illusion of a line our moving bucket produces. Three-dimensional flows of causality progress through volumes of space. This type of spatial progression is difficult to visualize. If anything, it might resemble the manner by which gas progresses through space. Thirdly, our bucket rotates because we pull it in the direction in which it moves. However, dimensional angles work differently. Dimensions produce dimensional angles, which carry three-dimensional flows of causality in the direction consistent to the regularities they sustain. In analogy, dimensional angles imply that to be similar to three-dimensional flows of causality, our bucket should not rotate because of the pull of the rope. Instead, it should rotate spontaneously. Moreover, it does not need to rotate at all. To explain, the dimension of motion demands all three-dimensional flows of causality must change their directions in all three spatial dimensions continuously. Therefore, using our common sense, we can deduce that three-dimensional flows of causality cannot be straight. A straight three-dimensional flow of causality implies that a flow does not change its direction along one dimension, and therefore, it fails to obey the demands of the dimension of motion along two of the three spatial dimensions. In other words, a straight flow is inconsistent with the dimensions our world spans, and therefore, it cannot exist. In addition, three-dimensional flows of causality cannot progress along a straight two-dimensional plane, for similar reasons. In short, three-dimensional flows of causality are curved. Nevertheless, even if three-dimensional flows of causality progress along curves, it does not imply any specific manner by which this progression must transpire. Arguably, to satisfy the dimensions of existence, causality, space, and motion, three-dimensional flows of causality could just as well move in a random fashion. Still, if they did, they would fail to coil around a central pivot, and therefore, inevitably, would fail to produce matter in the quantified form we know from our experience. Such three-dimensional flows of causality would fail to produce anything resembling particles or any other shape we could distinguish. Therefore, for matter to exist, the dimension of matter must segment a portion of the logical field in which three-dimensional flows of causality can revolve around a central pivot. Still, this does not imply all the three-dimensional flows of causality that exist in our world coil around a central pivot. To explain, according to the conclusions we reached in the previous chapter, three-dimensional flows of causality must exist everywhere within our world. Therefore, if all three-dimensional flows of causality were to coil around a central pivot in the manner particles require, it would imply matter exists everywhere within our universe. However, both our experience, as well as scientific experimentation, show that our universe is mostly empty of particles. Still, even if some three-dimensional flows of causality revolve around a central pivot, by itself, this is not enough to produce the particles we know from physics. Generally, the size of the particles we know from physics is uniform. To explain, particles such as atoms and subatomic particles do not inflate into the size of oranges, nor do they shrink from their original size. Indeed, implicitly, revolving around a central axis demands the existence of a maximal distance from this central pivot in which such three-dimensional flow of causality traverses. To explain, if there is no such maximal distance from the central pivot, it implies that either the flow does not expand in space at all, and therefore, it does not exist in our world, or that its maximal diameter is infinite. However, if its maximal diameter is infinite, such three-dimensional flow of causality should produce a particle the size of our entire universe, contrary to the limited sizes in which we find particles in nature. Moreover, generally, three-dimensional flows of causality, which rotate around a central pivot, can change their diameter. To explain, if we consider the three-dimensional flow of causality, which produces a particle, as a path, this path can scale to any size. While indeed, the minimal diameter surrounding the particle would be different, arguably, the path itself, meaning, the relative order and directions by which the three-dimensional flow of causality traverses, would remain the same. However, again, according to empirical findings, this does not occur. Indeed, through radioactive decay, particles may reduce their mass over time, and therefore, arguably, the minimal diameter, which can surround them, might change as well. Still, scientific experimentations show that radioactive decay obeys fixed quantified transformations, as particles transform from a specific unstable atom into another specific stable atom. Both atoms are of a specific mass and size, and therefore, essentially, radioactive decay does not breach the size uniformity particles exhibit. The size uniformity particles exhibit imposes a tough explanatory challenge. While the requirement to revolve around a central pivot is uniform to all particles, their size is not. Empirical experimentation shows that particles, such as atoms and subatomic particles, appear in many different sizes and mass. Therefore, unless we can prove all particles consist of constellations of particles of a specific size, our world cannot span a dimension to sustain this attribute directly. To explain, considering carbon-4 atoms, for example, they consist of 2 protons, 2 neutrons, and a few electrons. Furthermore, experimentation shows that protons and neutrons break down to even smaller subatomic particles, and therefore, arguably, they have an internal structure as well, meaning they might consist of several subatomic particles, of different sizes and mass. In short, a carbon-4 atom consists of a collection of subatomic particles, different in size and mass. Therefore, if carbon-4 atoms are to exist in a specific size throughout the universe, the size of all their ingredients must be uniform throughout the universe as well. To clarify, it is not enough that all subatomic particles of a specific type are of a uniform size. Their relative size, in comparison to subatomic particles of a different type, must be uniform as well. Therefore, even if a dimension was to fixate the size of one type of subatomic particles, a single atomic size is not enough. Moreover, not only may it require a collection of dimensions to fixate all different types of subatomic particles, but it requires dimensions to fixate the relative size of all different types of particles as well. Indeed, as we already mentioned, just as the dimension of space is three-dimensional, nothing demands the dimension of matter consists of one dimension. Still, fixating the relative sizes of different types of subatomic particles implies the dimensions which determine the uniform size of each type of subatomic particles exist within the span of another dimension, which provides a consistent space in which these dimensions exist. Therefore, the various relative uniform sizes of particles could not be the product of the dimensions our world spans, but rather of the dimensions our world hosts. In other words, such size-fixating dimensions would not affect our entire universe, as they reside merely in specific segments of our world. Moreover, experimentation has shown some subatomic particles exhibit small variations in both size and mass, and therefore, had a dimension our world spans fixated these sizes, such subatomic particles would be inconsistent with it, and therefore, arguably, these particles could not exist in our world, as they fail to adhere to the collective demands of the dimensions our world spans. To summarize, the dimensions our world spans cannot fixate the uniform relative size of subatomic particles directly. Still, we can solve the relative size uniformity of particles in a different manner. Instead of dedicating dimensions to determine the uniform relative sizes of particles directly, we can argue that the relative size uniformity particles exhibit is the product of dimensional angle equilibriums. To explain, the dimension of matter could indeed be a collection of dimensions, similar to the dimension of space. This collection can impose a collection of dimensional angles, which affect three-dimensional flows of causality. In some cases, these dimensional angles cause three-dimensional flows of causality to coil around a central pivot. Arguably, some of these coils of three-dimensional flows of causality might collapse into nothingness, as their diameter continuously shrinks to nothing. In contrast, some of these coils of three-dimensional flows of causality continuously expand. Arguably, we could think this implies we should find that some particles continuously expand. However, the dimension of existence does not allow the existence of such expanding particles. The dimension of existence demands that if a three-dimensional flow of causality is to produce an existing element, or alternatively, a dimension, this dimension must persist to exist. However, when a particle continuously expands, it does not persist to exist. As it grows in diameter, the flow which produces this particle changes repeatedly. This type of change is different from the type of change the dimension of motion demands, as it does not affect the manner by which flows move, but rather changes the metaphysical essence of these three-dimensional flows of causality. To clarify, we should remember that if three-dimensional flows of causality are to produce matter, the entire path they traverse must exist simultaneously. Therefore, if a three-dimensional flow of causality continuously expands, it implies this flow consists of its potentially infinite size, and not its finite size at any given point in time. Therefore, such a three-dimensional flow of causality must expand into the infinity of space, and therefore cannot fill merely a finite volume of it, in the same manner as particles. Nevertheless, some three-dimensional flows of causality manage to establish a stable maximal diameter from the central pivot around which they revolve. Potentially, such flows are eligible to produce particles. Moreover, because dimensional angles navigate these three-dimensional flows of causality, their formation occurs uniformly throughout space. Still, this implies the collection of dimensions composing the dimension of matter allow merely a limited variety of such stable three-dimensional flows of causality coils. To explain, the dimension of matter must do more than merely determine the relative sizes of particles. The dimension of matter must allow merely a limited variety of three-dimensional flow trajectories, which sustain a stable maximal diameter. Arguably, these specific stable maximal diameters are analogous to elementary particles, as the three-dimensional flows of causality which sustain them does not consist of smaller particles. However, such particles do sustain an internal structure. In fact, arguably, they consist of nothing else. Therefore, this is not really a problem. It is merely an observation. Moreover, we will refrain from analyzing the dimensional collection that compile the dimension of matter, as this discussion is no longer metaphysical. It is pure physics. Such discussion should not transpire in a book about metaphysics, but rather, in a laboratory, while analyzing empirical findings. Still, there is one observation we can deduce, without performing a rigorous empirical study. As we previously explained, the three-dimensional flows of causality, which coil around a central pivot and produce particles, do not exist as single points, moving in space. As we already explained, the entire path by which three-dimensional flows of causality traverse must exist simultaneously. Causality coils in all three spatial dimensions, within the volume of a particle. However, because causality is not composed of particles, causality cannot be thick, and therefore does not fill any volume. Therefore, within the volume of a particle, causality coils endlessly, and therefore, essentially, the manner by which causality coils within particles is identical to the manner space expands into infinity. In short, our initial assumption, meaning that only dimensions exist in our world, remains valid. The coils of causality, from which particles consist, are dimensions. Still, obviously, these are not the dimension our world spans, but rather dimensions our world hosts. This observation will be crucial to the continuation of our journey. To conclude, we have managed to incorporate matter into our cosmology. Still, there are more issues to discuss, such as the manner by which the dimension of matter allows physical elements to interact in space, meaning forces, fields, and the likes. Indeed, as we just mentioned, without scientific experimentation, we cannot analyze the dimensional collection the dimension of matter embodies. Therefore, unlike the previous dimensions we discussed, we cannot analyze the dimension of matter in the same manner we analyzed dimensions previously, meaning analyzing the manner by which we can span the dimensions of existence, causality, space, and motion, from a one-dimensional singular world, consisting only of the dimension of matter. Nevertheless, the dimensions we already discussed expose some non-trivial behaviors which the dimension of matter must exhibit. For example, let us consider the issue of empty space. Intuitively, we could think that the dimension of matter implies that matter exists, while empty space does not. However, this intuition is wrong. As we explained in the previous chapter, the logical field does not allow the existence of elements which interrupt the persistent expansion of space. Therefore, both matter and empty space must exist in our world. Furthermore, because our world spans the dimensions of motion and causality as well, the entire span of space must sustain the regularity of motion, regardless if it is populated or empty. Moreover, because our world spans the dimension of matter, empty space must sustain the same regularities as matter. Therefore, three-dimensional flows of causality must exist in empty space, just as they exist in matter. To summarize, essentially, the dimension particles coil within their volume is the only difference between particles and empty space. Nevertheless, semantically, there is a significant difference between the three-dimensional flows of causality that exist in matter, and the three-dimensional flows that exist in empty space. The three-dimensional flows of causality, which do not create matter, affect matter, meaning they move matter in space. Still, because these three-dimensional flows of causality do not coil infinitely around a central pivot, while sustaining a stable maximal diameter, they cannot yield dimensions. Therefore, they are not an element our world hosts, meaning these three-dimensional flows of causality consist of a single element. We will call this element the antimatter flow. The antimatter flow binds all the particles our world harbors with a three-dimensional web of causality. It ensures all physical changes within our world occur due to consistent progression of causality throughout space. Still, there is more to it. Essentially, particles, slice, segments from the antimatter flow. In other words, the antimatter flow flows through matter, just as it flows through empty space. Therefore, essentially, matter and the antimatter flow are interchangeable, or alternatively, the antimatter flow is the energy to which Einstein's theories of relativity refer. Still, because particles coil infinite flows of causality, while empty space does not, then potentially, the antimatter flow in particles could be infinitely more energetic than the antimatter flow in empty space. Therefore, contrary to Einstein's theories of relativity, matter might not be able to convert into pure energy, or alternatively, pure antimatter flow. While indeed, matter can decompose, if it does, then arguably, it must retain its infinite causality within smaller particles. To explain, the infinite causality a particle coils within itself could shift between one diameter equilibrium to another diameter equilibrium. Nevertheless, nothing forbids a finite volume of empty space from harboring infinite three-dimensional flows of causality in the same manner as particles. Still, if empty space of a finite volume cannot harbor such infinite three-dimensional flows of causality, it would imply the matter in our universe cannot spore out of the antimatter flow, as the antimatter flow is insufficiently energetic. Indeed, this hypothesis is problematic, as it raises the question regarding the origins of matter. To explain, if matter cannot spore out of the antimatter flow, then arguably, there is no other element which could yield it. Still, this does not imply empty space must harbor infinite three-dimensional flows of causality in the same manner as particles. In fact, if it does not, it is consistent with our previous assumption, meaning that each particle coils a dimension within it. To explain, the dimensions our world spans are independent of one another. They do not produce each other. Therefore, if empty space is insufficiently energetic to provide the causality required to yield the dimension a particle harbors, it implies that the dimensions our world harbors are not the product of the dimensions our world spans. Metaphysically, their existence is independent of the dimensions that harbor them. Therefore, arguably, the very existence of particles is paradoxical. Nevertheless, the existence of particles within our world is self-evident. Therefore, essentially, there is no significant metaphysical difference between the existence of the dimensions our world spans and the existence of the dimensions our world hosts. Both the dimensions our world spans and the dimensions our world hosts could be independent entities, meaning they exist in the logical field because they can exist in the logical field as no other dimension forbids it. Still, again, we cannot assert these conclusions using metaphysics. Their assertion requires scientific facilities, which this text cannot provide. Nevertheless, again, even without knowing the specific dimensions which compose the dimension of matter, we can deduce many aspects imperative to the antimatter flow. Essentially, the antimatter flow is the world the dimensions of existence, causality, space, motion, and matter span. Just as the dimension of space sustains the same regularity of spatial expansion in every corner of our world, the antimatter flow is uniform throughout the universe. Considering this, we can describe the antimatter flow in different manners. To explain, as we concluded in the previous chapter, all dimensional spanning orders are equally possible. Therefore, we should not perceive the antimatter flow merely as the world, which spanning the dimension of matter from the dimensions of existence, causality, space, and motion, produces. Our world could have spanned each of these dimensions, after spanning the dimension of matter. Moreover, the imperative implications each subset of the dimensions our world spans demand, must be true to our world as well. Indeed, as we understood in the previous chapter, each such dimensional subset, or alternatively, subworld, is less restrictive than our world. Still, our world must obey the limited metaphysical restrictions these subworlds demand. This observation is crucial to several fundamental aspects of the antimatter flow. If we consider the spanning order, in which the dimension of space spans last, we can deduce that the dimensional angles we discussed previously cannot exist as similar copies across the infinity of space. Ontologically, each location in space harbors the same dimensional angles. In other words, the rules which govern the trajectory of three-dimensional flows of causality are uniform. Previously, we utilized this conclusion to explain the relative size uniformity particles exhibit. However, this conclusion implies another fundamental principle. if several three-dimensional flows of causality sustain the same trajectory, while the three-dimensional flows of causality surrounding them are the same as well, then unless an additional element would alter the state similarities between these three-dimensional flows of causality, the manner by which their trajectory would continue must be identical. Furthermore, not only must such identical three-dimensional flows of causality proceed along an identical path, the rate by which these three-dimensional flows of causality progress in space must be identical as well. To explain, essentially, the dimensions of existence, causality, motion, and matter cannot differentiate between them. In fact, they cannot notice them at all. Moreover, if we decompose the dimensions of our world even further, and consider the world the dimensions of existence, causality, motion, and matter, as the world the dimensions of existence, causality, and motion produce, after spanning the dimension of matter, we can deduce that all dimensional angles demand the same rate of progression. To explain, while the dimensional cluster we call the dimension of matter may impose different dimensional angles in different dispositions, the dimension of motion cannot differentiate between them. The dimension of motion imposes the same rate of progression on all the dimensions it affects. In short, within our world, the speed of causality is uniform. Moreover, considering Einstein's theory of relativity, then arguably, this uniform speed of causality might be analogous to the speed of light. Nevertheless, obviously, this does not imply all elements in space move at the same speed. Usually, when we discuss the speed of an element, we refer to the rate by which this element crosses distances in a straight trajectory. However, as we already understood, within our world, the trajectory by which causality can flow must be a curve. Again, if a three-dimensional flow of causality fails to change its direction in one of the three spatial dimensions, it fails to sustain the demands the dimension of motion imposes along at least one of the three spatial dimensions, and therefore, it can no longer exist in our world. Therefore, essentially, our common concepts regarding speed are irrelevant to the logical physics. Still, there is more to it. As long as its trajectory is curved in a manner consistent with the dimensional angles the dimension of matter imposes, the antimatter flow can progress at the speed of causality. In fact, as we already explained, the antimatter flow cannot travel at any other rate. However, matter cannot travel at the speed of causality. But why? Well, as matter travels through space, at any given moment, it progresses, or alternatively, flows, toward a specific direction. Still, as we already explained, matter coils three-dimensional flows of causality, meaning, motion exists within particles, regardless of the speed in which particles travel as a whole. To summarize, the rate at which causality flows through particles, compose of two components. 1. The rate at which three-dimensional flows of causality move within particles. 2. The rate at which three-dimensional flows of causality moves the particle in its entirety. Both components are imperative. If three-dimensional flows of causality fail to move within a particle, the particle can no longer exist. If three-dimensional flows of causality fail to move the particle in space, the particle can no longer exist within our world. Nevertheless, both components exist in our world, and therefore, both components impose spatial motion. Moreover, at some section of the particle, the three-dimensional flow of causality which composes it must progress at a direction parallel to the direction at which the particle moves as a whole. To explain, the three-dimensional flows of causality of which a particle consists are consistent flows. They are not a collection of sporadic appearances of flows in different directions, but rather an endless continuous path. Therefore, they must progress in all possible directions. If not, then from one direction, the particle would not exist, while from other directions, it would. In short, such a particle would be an inconsistent element, and therefore could not exist within the logical field. Still, as we just explained, within our world, the rate at which causality flows is both constant and universal. Therefore, at no time can one of the two components reach the speed of causality. If any of the two components manages to reach the speed of causality, such particle could no longer exist in our world. While our last conclusion provides us with many insights regarding physics, unintentionally, we introduced an explanatory gap into our metaphysical model. We discussed and utilized concepts such as the rate, or alternatively, speed of causality. However, as we already concluded, the rate at which causality progresses in space is constant. Therefore, to close this explanatory gap, we must explain the essence of three-dimensional velocity. Naturally, velocity is a relation between our world and the elements it hosts. Therefore, essentially, velocity involves dimensional angles. Still, on its own, velocity does not produce matter, and therefore, arguably, to understand it, we need not understand the regularities the dimension of matter sustains. We should merely understand the extent of our previous conclusions regarding the antimatter flow. As we already explained, unlike particles, the antimatter flow is a product of the dimensions our world spans, and not of a dimension our world hosts. Therefore, nothing slices the antimatter flow into a specific trajectory, and therefore, at any point in space, it must progress along all possible spatial directions simultaneously. Still, because the antimatter flow must exist, and because our world spans the dimension of motion, the antimatter flow cannot impose a stagnating kinetic equilibrium. Therefore, unlike the infinite flow, the progression of the antimatter flow in each spatial direction is different. In other words, at any point in space, the antimatter flow imposes a different dimensional angle along each of the three spatial dimensions. Still, what does that mean? Well, to understand this, let us reuse our bucket analogy. The size of the circular shape our rotating bucket creates depends on the length of the rope with which we rotate the bucket. The longer the rope, the larger the circular shape becomes. Dimensional angles work in a similar manner. All dimensional angles progress along a curved trajectory, and therefore, in many ways, these paths are circular. Still, the implicit diameter of the curve, which dimensional angles impose, can be different. The longer this implicit diameter becomes, the more the dimensional angle pushes the physical element it carries in space, in the direction vertical to its implicit radius. The smaller the diameter, the less the dimensional angle pushes the physical element it carries, in any specific direction. Therefore, the accumulation of all dimensional angles in all directions generates both a single azimuth, at which they push the physical element they carry, as well as its specific rate of progression. Moreover, because this effect is not the product of a specific dimension our world harbors, nothing restricts the direction and rate of progression by which physical elements can move in space to a specific non-continuous set of possible velocities. Therefore, essentially, unless a movement is impossible, meaning if it does not change its direction along at least one spatial dimension, or if it suggests progression of particles at a rate either identical or greater than the speed of causality, any direction and rate of progression is possible. Moreover, arguably, when the implicit diameter dimensional angles impose is sufficiently small, the three-dimensional flow of causality might coil around itself, and therefore, it might yield a particle. However, again, validating or refuting this hypothesis demands empirical study, which this text cannot provide. Nevertheless, we should note that according to the explanation we just provided to the essence of velocity, velocity is local. Velocity is not the relative rate at which a physical element approaches or distances itself from another physical element. In fact, according to the logical physics, ontologically, the relative velocity between two elements within our world cannot exist. But why? Well, as we already explained so many times before, according to the physical logic, only dimensions exist in our world. Moreover, being dimensions, all existing elements within our world must exist independently from one another. However, the relative speed between two physical elements is dependent on the speed at which both elements travel, and therefore cannot be a dimension, and therefore it cannot exist in our world. In short, the logical physics solves the question, what is the relative speed between two elements traveling toward each other, each at the speed of causality? In the manner similar to the manner Einstein's theory of relativity solves it. This relative velocity does not exist. It exists merely as an idea in our mind. It is a definition that does not exist, and therefore, it belongs in the inconsistent segment of the dimension of consistency. Moreover, being the product of dimensional angles, velocity is not an existing element in our world as well. Nevertheless, it is still a partial attribute which all the elements within our world must exhibit. The question regarding relative speeds of physical elements approaching each other, each at the speed of causality, raises an issue we have not yet discussed. Three-dimensional flows of causality can coil around a central pivot in a manner different from that of particles. Indeed, particles cannot move in space at a rate equal or faster than the speed of causality. Still, generally, this does not imply that the elements our world hosts cannot travel at the speed of causality. To explain, the reason particles cannot move at the speed of causality is because their internal structure demands that the three-dimensional flows of causality of which they consist must move in all spatial directions, including the direction in which the particle moves. However, three-dimensional flows of causality can coil around a central pivot in a different manner. To explain, the central pivot around which a three-dimensional flow of causality revolves can travel at the speed of causality. Indeed, in such a case, the three-dimensional flow of causality could not consist of any trajectory in the direction in which the central pivot moves, other than the movement of the central pivot itself. Still, this pivot is not a particle, and therefore, it does not exist in our world. Essentially, this pivot is merely a trajectory the antimatter flow sustains, regardless if causality coils around it or not. Still, potentially, this revolving motion can persist to exist forever, and therefore, arguably, it might facilitate the existence of a dimension. Nevertheless, revolving in such a manner cannot yield a particle, as it cannot surround any volume. Still, such revolving three-dimensional flow of causality is different from the antimatter flow in its raw form. Essentially, such three-dimensional flows of causality compose the physical element we know as light, or alternatively, photons. As we just explained, because photons cannot surround any volume, they cannot yield particles, and therefore, obviously, photons are not particles. Nevertheless, again, photons are different from the raw three-dimensional flows of causality, which exist in empty space, as they carry a focused three-dimensional flow of causality with them. Moreover, the amount of three-dimensional flow of causality a photon can carry can vary. However, obviously, photons accumulate three-dimensional flows of causality in a manner different from the manner particles accumulate three-dimensional flows of causality. Again, photons cannot fill or surround any volume, and therefore, the three-dimensional flow of causality of which they consists merely of the implicit surface on which they rotate. Still, unlike particles, the amount of three-dimensional flow of causality they carry along the direction of their trajectory can become smaller the bigger this surface becomes. To explain, the three-dimensional flow of causality, of which photons consist, is the three-dimensional flow of causality that causes them to sustain the rotation. The more this three-dimensional flow of causality is dominant, the more it changes the direction of three-dimensional causality, while zooming in space. Therefore, the maximal diameter of this implicit surface determines the causality this three-dimensional flow carries, only partially. To explain, three-dimensional flows of causality exist in the antimatter flow, which empty space harbors, regardless if photons travels through it or not. However, in empty space, this flow travels without any inclination to rotate around a central pivot. Therefore, the more the antimatter flow imposes a three-dimensional flow of causality, which does rotate around a central pivot, the more it harnesses additional three-dimensional flows of causality. Therefore, on their own, neither the maximal diameter, nor the rotation speed, determine the amount of causality such three-dimensional flows carry. The same amount of additional three-dimensional flows of causality can cause a fast rotation around a small diameter, or a slow rotation around a large diameter. Considering this, the amount of three-dimensional flows of causality, of which photons consist, need not be fixed to specific diameter equilibriums in the same manner as particles, as essentially, different dimensional angles govern them. Arguably, unlike particles, the scale of possible amounts of three-dimensional flows of causality, of which photons consist, might be continuous. Moreover, this metaphysical explanation for photons is consistent with empirical findings regarding the relation between the amount of energy light conveys and its frequency and amplitude. Still, again, it is best we refrain from prolonging our discussion regarding this issue, as it is no longer in metaphysics. Moreover, discussing the amounts of three-dimensional flows of causality, outside the context of particles, is ambiguous. Therefore, it is best we refrain from it. Understanding the nature of the antimatter flow can provide an explanation to the essence of gravity as well. As we just explained, the antimatter flow progresses in all spatial directions simultaneously. When in contact with particles, it causes them to move at a specific direction and rate. The particles absorb this three-dimensional flow of causality by merging it with the three-dimensional flow of causality which composes them, and move in space accordingly. However, obviously, in the absence of matter, this cannot happen. Nevertheless, as we already explained, the antimatter flow must exist in empty space as well. Still, being a three-dimensional flow of causality, the antimatter flow must inflict three-dimensional causality. Therefore, in the absence of any better candidate, in empty space, the antimatter flow can only inflict three-dimensional causality on itself. Therefore, in empty space, the antimatter flow continuously increases its local velocities, as at any point in space, it pushes the three-dimensional flow of causality approaching this point, further in the direction to which it already flows. Naturally, the speed of causality imposes a limit to this acceleration. However, the larger the section of empty space, the greater the expected local velocity, at which the three-dimensional flows of causality it harbors, travels in all spatial directions. In short, the greater the volume of empty space, the greater the local velocities at which the antimatter flow travels within it. Still, because in empty space, the local velocities of the antimatter flow increase in all spatial directions, if a particle finds itself alone in empty space, the three-dimensional flows of causality coming from each direction mostly cancel each other out, and therefore, such a particle would remain relatively stationary. Its internal flow component will become greater, meaning, the rate at which the three-dimensional flows of causality, which compose it, would travel, would be faster. Alternatively, its internal time would run faster than when traveling fast in a specific direction. However, when two or more particles are nearby, a different process emerges. As each particle absorbs the three-dimensional flows of causality originating from empty space, it shadows these three-dimensional flows of causality in the directions of nearby particles. To explain, between the particles, the volume of empty space is significantly smaller, and therefore, the local velocities at which three-dimensional flows of causality travel between these particles is significantly smaller as well. As a result, the particles gain a velocity and azimuth toward their neighboring particles. While from afar, it appears as if they attract one another, in actuality, they are pushed toward one another by the collective three-dimensional flow of causality, originating from the immensity of empty space behind them. This process accumulates the more particles it affects. To explain, the nearby particles create a bigger collective shadow of the three-dimensional flow of causality, originating from empty space. In other words, the more particles are nearby, the lesser the volume of empty space between them becomes, and therefore, the less there is empty space to generate the three-dimensional flows of causality, which would otherwise repel them. In short, this process produces the force we know as gravity. Still, this implies that unlike our intuitive notions, we are not pulled toward the Earth, but rather pushed toward the Earth by the immensity of empty space above us. Moreover, this explanation solves the mystery black holes impose on science. If empty space is the source of the force, which sustains gravity, and not mass, there is no reason why black holes should impose any type of abnormality or metaphysical singularity, as essentially, it implies there is nothing in the center of a black hole, other than empty space. To explain, there is a reason why black holes appear at the center of galaxies and not in their outskirts. A black hole is a section in space, in which the repelling three-dimensional flow of causality, which empty space generates, is equal to the repelling three-dimensional flow of causality, with which the entire empty universe is pressuring the galaxy harboring this black hole. In fact, the reason this equilibrium is possible is exactly because an entire galaxy surrounds it. The collection of stars and planets which compile the galaxy shield most of the antimatter flow arriving from the vastness of empty space, and therefore allows a relatively small section of space to accumulate enough repelling flow to sustain this equilibrium. Still, the shield of stars and planets which galaxies provide for black holes exists only when stars and planets lie in the path of the antimatter flow. To explain, if a galaxy is relatively flat, the shield will be flat as well. On the axis of this shield, the black hole will repel matter from it, while from an axis vertical to it, flows could pass through it. In fact, this might explain the appearance of jets of particles, gashing from the sides of black holes, which according to contemporary physics, could not occur, as the particles of which they consist should not be able to escape the gravitational pull the black hole generates. To summarize, the logical physics sets itself apart from other theories in physics, as it rejects the existence of a gravitational force of attraction. In fact, according to the logical physics, the same applies to all fields. There are no attraction forces in our universe, as no dimension sustains them. Moreover, arguably, attraction forces are inconsistent, as they imply the dimension which sustains this attraction must be aware of the elements it affects, contrary to the independent nature of dimensions. To explain, for attraction forces to occur, a signal must travel between all the attracted elements, so that elements would know to which direction they should move. Contemporary physics have confronted this issue by introducing the concept of the fabric of space-time. However, contemporary physics overlooked one significant problem the fabric of space-time raises. The fabric of space-time possesses attributes it does not define, such as the metaphysical space in which it exists. Therefore, metaphysically, the fabric of space-time cannot be a dimension our world spans, but rather an element our world hosts. However, according to contemporary physics, the fabric of space-time is a dimension our world hosts, and therefore, the fabric of space-time breaches the imperative restrictions of consistent worlds, meaning, it demands the coexistence of irrelevant worlds. Such problems cannot occur with repelling forces, such as the one the antimatter flow propagates, because repelling forces demand merely a point of impact and not a relation between two distant points in space. To explain, let us consider the process that occurs whenever two particles collide in space. As we already explained, the three-dimensional flow of causality, which both particles carried prior to the collision, consisted of two components, meaning, the three-dimensional flows of causality, which sustained their existence as particles, and the three-dimensional flows of causality, which sustained their movement in space, meaning, their existence within the span of the dimension of motion. Once the two particles are in contact, two processes can occur. If the regularities the dimension of matter sustains allows it, the three-dimensional flow of causality, which sustains the existence of one particle, will merge with the three-dimensional flow of causality, which sustains the existence of the other particle, and therefore, the two particles will merge into a bigger particle. This can happen in many ways, either as a chemical reaction, an electron ionizing an atom, or the fusion of two atoms into a new atom. In such a case, the additional three-dimensional flows of causality, which previously propelled these particles in space, eject from both particles back into empty space, or alternatively, back into the antimatter flow in its raw form. Still, as we already explained, the dimension of matter allows three-dimensional flows of causality to sustain particles selectively, and indeed, in many cases, it does not permit such a merger. In such cases, the three-dimensional flows of causality which sustain such two particles cannot share the same space. Therefore, a different process occurs. Again, the three-dimensional flows of causality, which sustain the existence of the two particles, cannot interact with one another. However, essentially, the kinetic component, which propelled the particles through space, was external to the three-dimensional flows of causality, which sustained the existence of these particles, and therefore, this component can shift between the two particles. Moreover, because the particles cannot continue to move in their original direction, their internal flow component is free to flow closer to the speed of causality, while forcing the component responsible for external motion to eject from it. Therefore, the three-dimensional flow of causality, which moved one particle, progresses in the direction of the other particle, while the three-dimensional flow of causality, which moved the other particle, progresses in the direction of the first particle. In short, the two particles switch the three-dimensional flows of causality, which previously propelled them in space, and therefore, at the end of this process, the two particles repel from one another. Still, again, unlike forces of attraction, at no point during this process was any dimension aware of any other dimension. Therefore, this process retains the consistency of all the dimensions taking part in it. To summarize, we have managed to explain the essence of matter, empty space, velocity, gravity, and physical collisions. Still, we must provide an explanation for the two fundamental forces we did not explain yet, meaning electromagnetism and radioactivity. Arguably, without first finding the dimensions that compile the dimension of matter, we cannot explain the essence of these forces. Essentially, both electromagnetism and radioactivity are inherently dependent on the regularities particles sustain, or more specifically, the demands the dimension of matter imposes. Nevertheless, we can still provide important insights about them. Moreover, these insights will be crucial for the continuation of our journey, and therefore, we must address them. First, we must remember the distinction between the dimension of matter and the dimensions that coil within particles. While the dimension of matter exists everywhere in our world, the dimensions that coil within particles are local. Moreover, the actual manner by which three-dimensional flows of causality create particles is not the product of the dimensions that coil within particles, but rather of the dimension of matter. Still, again, throughout the universe, the dimension of matter is uniform. It sustains the same regularities everywhere. In other words, from the perspective of the dimension of matter, the existence of particles is identical to the existence of empty space. The only meaningful difference between particles and empty space is that within particles, three-dimensional flows of causality revolve around a central pivot. The dimension of matter does not care how this happens. To explain, as long as three-dimensional flows of causality do not untangle and escape their endless flow within a particle, the dimension of matter remains oblivious to the internal structure of particles. In other words, as long as the internal structure of a particle does not break down, the dimension of matter treats matter as a single entity moving in space, regardless if it is a subatomic particle, an atom, or even a molecule. Nevertheless, obviously, in certain conditions, the internal structure of particles breaks down. For example, we can easily decompose molecules using electric currents, radiation, or chemical compounds. Still, this does not imply that the physical attributes molecules sustain are the product of the collection of atoms that compose them. It merely determines that at a certain condition, such structure can no longer exist, or alternatively, that the three-dimensional flow of causality, which composes a molecule, becomes inconsistent with the dimension of matter. This conclusion contradicts the manner by which empirical sciences perceive matter. Empirical sciences, or alternatively, contemporary physics, endorse the belief that because some particles can break down to other smaller particles, then essentially, these original, larger, particles merely represent the constellation of the particles of which they consist. However, again, from the perspective of the dimension of matter, this internal structure might be irrelevant. Even if by using powerful microscopes we can actually see the internal structure of molecules, meaning even if we think we see empty space between the atoms which compose a molecule, it does not imply we see everything. Just as the antimatter flow in empty space is invisible, significant portions of the three-dimensional flows of causality, which compose a molecule, can be invisible as well, regardless if this three-dimensional flow of causality plays a significant factor in both the formation of the molecule and its physical attributes. To summarize, neither the particles to which other particles can break down, nor their distribution in space, can describe the internal structure of the three-dimensional flow of causality, of which matter consists. Moreover, arguably, the fact a particle breaks down to smaller particles does not automatically imply these smaller particles even existed prior to its decomposition. To explain, while in its stable form, a particle can consist of a single infinite three-dimensional flow of causality, which coils around a central pivot, it can still break down to several smaller particles. In fact, if we apply the laws of mathematics, which determine that infinity remains infinite, regardless of any finite number by which we divide it, then potentially, the infinity of three-dimensional causality a particle harbors, can split into any finite number of subsets, all of which would remain infinite. Moreover, as we split a particle, some of its original three-dimensional flow of causality might eject from any particle whatsoever, and convert into either photons, or the antimatter flow, in its raw form. Therefore, if such three-dimensional flow of causality took part in the original internal structure of the particle, we can even argue that the components to which our particle broke down did not even exist prior, as their very existence might demand this removal. To summarize, according to the logical physics, we should not perceive particles as the constellation of subparticles, to which particles can break down. Instead, we should view these subparticles as lumps of causality, entangled in the flow of which the original particle consists. Moreover, these lumps might not even consist of dimensions, separate from that of the particle of which they allegedly consist. In other words, particles are more than the sum of their parts, as arguably, as long as particles exist, their parts might not yet exist. Considering this, even without a detailed understanding of the dimensions compiling the dimension of matter, metaphysically, we can provide a partial explanation to electromagnetic and radioactive forces. From our experience, we know both the repelling and attraction forces, which magnetism generates. In addition, common knowledge in physics tells us we can create these forces by ionizing particles with either positive or negative electric charges, meaning by adding additional electrons to particles, or removing electrons from particles, respectively. Still, this ionization process does not change the general attributes of these particles significantly. Apart from their electromagnetic qualities, and a small variation in their mass, such particles remain the same. To explain, when we ionize particles, or more specifically, atoms, we do not change their attributes in any way similar to the radical manner by which we change them when altering their nucleus. Moreover, these magnetic forces are both invisible and selective considering the particles they can affect. Empirical sciences explain these forces using a concept we know as electromagnetic fields. However, considering our previous conclusions, we can provide a slightly different explanation. Electromagnetism suggests that the three-dimensional flows of causality, of which particles consist, sustain a particularly strange type of tolerance. We can both add to, or remove from particles, specific segments, or alternatively, lumps, of three-dimensional flows of causality. We know these lumps by the name, electrons. Empirical experimentations show these segments are both marginal in the amount of three-dimensional flow of causality they encapsulate, and are relatively distant from the central pivot around which the three-dimensional flow of causality, of which particles consist, revolves. Nevertheless, these lumps are an integral part of the dimensions of which particles consist. Therefore, changing the number and distribution of these lumps changes the trajectory of the three-dimensional flow of causality, of which particles consist. Adding or removing any of these lumps cause three-dimensional flows of causality to extend beyond the normal diameter, which would otherwise impose a spatial limit for them. Still, apparently, the portion exceeding this normal diameter does not expand in all spatial dimensions evenly. As experiments in electromagnetism show, this three-dimensional flow of causality exits the particle's normal maximal diameter from one side of the particle and returns to its original maximal diameter at the opposite side. Therefore, it fails to extend the maximal diameter of the particle in all spatial directions, and therefore, fails to extend the volume of space the particle surrounds. Still, this extension affects the antimatter flow. Nevertheless, apparently, it could only affect particles, which manipulate the dimensions which compile the dimension of matter in a specific manner, meaning, mainly metal elements. These elements consist of three-dimensional flows of causality, which are more tolerant to either the removal or addition of such lumps as well as more responsive to the flow extensions they cause. Therefore, while indeed, we did not explain the exact reason why such three-dimensional flows of causality occur, arguably, their existence in nature is consistent with our metaphysical foundation. Using similar principles, we can explain radioactivity. Apparently, the three-dimensional flows of causality, of which some particles consist, is frail. Some particles fail to coil the three-dimensional flow of causality robustly, and therefore, they continuously eject some of the three-dimensional flow of causality they harbor, through different types of radiations. While some types of radiation can consist of lumps, similar to the lumps we discussed while analyzing electromagnetism, some of them consist of either photons, or raw antimatter flow. Still, again, without relying this discussion on empirical data, there is no point analyzing this process in detail. Nevertheless, radioactivity imposes a special challenge, which we did not yet explain. Empirical experimentations show that apparently, radioactive decay occurs in a random fashion. While we can predict the probability a particle will undergo radioactive decay, science fails to find a deterministic process which predicts it. Therefore, it appears something else occurs in matter, something we have not yet discussed. Moreover, experimentations in quantum physics show the occurrence of other strange types of physical behaviors. For example, the phenomenon we know as non-locality implies a special type of causality, which arguably travels faster than the speed of causality. At first glance, it appears we have a problem. Our metaphysical foundation rejects the feasibility of such behaviors. Nevertheless, there is one special factor which governs these arguably nonsensical empirical findings. It appears that if we observe them, we change the manner these behaviors occur. In other words, we, the observers, or alternatively, we, consciousnesses, play our factor in these behaviors. Still, we have not yet explained the existence of consciousness within the logical field, and therefore, currently, we should postpone our discussion regarding these. Nevertheless, we have provided explanations for all the prime physical forces in our world, meaning nuclear forces, gravity, electromagnetism, and radioactivity, in a manner consistent with our metaphysical foundation. Obviously, we neglected the discussion regarding some issues, such as thermodynamics, and probably many others. However, because we provided explanations for both matter, light, empty space, and the four prime physical forces, then arguably, we can use the explanations we already provided to extrapolate metaphysical explanations for these issues as well. Still, again, because this text deals with metaphysics, then naturally, it cannot even attempt to provide the empirical findings necessary to assert these extrapolations, and therefore, there is little point to continue these discussions in this text. Moreover, this text suggested merely one possible set of explanations, consistent with our metaphysical foundation. Possibly, we could find a different set of explanations as well. Moreover, there is no point to insist the set of explanations this text provided is either correct or exact. Moreover, because we did not describe the dimensions, which compile the dimension of matter, then obviously, there are many issues our set of explanations did not cover. Nevertheless, it is good enough. While indeed, some of the metaphysical explanations we provided are not traditional, they do not contradict empirical findings significantly. Therefore, it is safe to assume that even if the set of explanations we provided is inexact, a similar different set of explanations could correct the mistakes of our current set. Moreover, considering the level of consistency between our set of explanations and empirical findings, then arguably, it is not likely we could not find another similar explanatory set, consistent with all empirical findings. To summarize, we will end this chapter with the hypothesis that there is a theory in physics, similar to the logical physics, which is consistent with all empirical findings, as well as with our metaphysical foundation, meaning the physical logic and the logical cosmology. Moreover, we will assume this theory in physics is consistent with three of our previous conclusions. 1. Particles consist of local dimensions, meaning three-dimensional flows of causality, which coil around a central pivot. 2. Through physical interactions, lumps of the three-dimensional flows of causality, of which particles consist, can affect and reintegrate within other particles. 3. Empirical findings suggest we cannot explain some physical behaviors using a consistent foundation that merely allows the existence of matter. Considering item number 3, as we just explained, it appears our consciousness plays a factor determining these strange behaviors. Therefore, arguably, to complete our theory in physics, we should understand the essence of our consciousness. Still, obviously, first we must understand the essence of life. In other words, it is time we introduce life into the logical field.